altitudes are concurrent, and then we proved that the angle in a semicircle is a right angle. All that we proved by using vector method. Now we have an important example. This is very, very important. So prove that the angle theta between any two diagonals of a cube is given by cos theta is equal to 1 by 3. So that means if theta is the angle between any two diagonals of a cube, then show that cos theta is equal to 1 by 3. Now we have the formula that if A and B are two vectors, then the angle between two vectors is given by the formula cos of AB is equal to A dot B by mod A into mod B. So we are using this formula. We are going to use this formula. Now what we do is, first we'll draw the figure. Draw a cube like this. Draw two squares. Learn how to draw the cube. Draw a square and again draw another square. Draw another square and then join like this. So this is the cube. Now take this as x-axis. This is x-axis and this is y-axis and this is z-axis. Now the cube can be of any size. The side can be 1 unit or 2 units or 3 units. Whatever may be the length of the side, the angle between diagonals will be same always. So what we do is, we'll take a unit cube. Unit cube means the length of the side is 1 unit. 1 unit. So now because this is along x-axis, suppose that this is the origin. Now A, B, C, D and then E, F, G. So suppose that OA, B, C, D, E, F, G be the unit cube. So this length is 1 unit, this length is also 1 unit, like that. So because we know that along x-axis, OA, along x-axis, the unit vector is I. Along y-axis, the unit vector is J. Along z-axis, the unit vector is K. So OA will be just I. And then OG will be J. And then OE will be K. So you choose the coordinates like this. Choose the unit cube like this. So we'll write the steps like this. Let O, A, B, C, D, E, F, G be a unit cube. Unit cube. Now let O be the origin. Let O be the origin. Now along OA is along x-axis. Let O be the origin. X-axis is along OA. So the x-axis is along OA. So implies that OA is equal to x I. OA is equal to I cap. Similarly, y-axis is along OG. Along OG, positive y-axis, positive x-axis. So this implies that OG is equal to J. OG is equal to J. Similarly, the positive z-axis is along OE, along OE. So this implies that OE vector is equal to K. Now we'll take the diagonal. The diagonal of the cube is you join one vertex of base and opposite side, top side, you should take the vertex, join those two. Those two will be the diagonal. So when you take this point as one vertex, then the other vertex opposite to it in the opposite side will be C. So OC will be one diagonal. Similarly, D, if you take D, then DG will be another diagonal. And then if you take E here, then EB will be another diagonal. And fourth diagonal is A, and then A is this side. So AF will be another diagonal. So you take any two diagonals. So we'll take OC. OC is one diagonal. So we'll take diagonal OC is equal to diagonal OC is equal to. So when you take OC, in this according to triangle law of vectors, OC is equal to OB plus BC. OC is equal to OB plus BC. Now again, what is OB? OB is nothing but OA plus AB. So write OB as OA plus AB. OA plus AB plus BC. But what is BC? BC is same as OE. BC and OE are equal. They are in the same direction, BC and OE. So I'll write this OA and then again AB also. AB is equal to OG because they are in the same direction. OAB and OG are in the same direction and they are equal also. So we'll write AB as OG and then BC is OE. BC is OE. So when you substitute the values, OA is I, OG is J, OE is K. So this becomes I plus J plus K. I plus J plus K. So now we'll take another diagonal. Another diagonal I can take as BE or EB. Suppose I take as EB. Another diagonal EB. So EB is equal to diagonal EB is equal to diagonal EB is equal to EO plus OB. EO plus OB according to triangle law of vectors. EO plus OB. But what is E? We know OE. OE is K. So EO means it is minus OE. When you interchange the initial and terminal points, you should change the sign. So you are writing minus OE. Now again, what is OB? OB is OA plus AB. But again, AB is OG. So we'll substitute like this. So it is OA plus AB. OB is OA plus AB. So this is minus OE plus OA plus AB is, I'll substitute directly. So it is OA plus OG. OA plus OG. So it is equal to minus K plus I plus J. Or it is equal to I plus J minus K. So these are the two diagonals. OC is one diagonal and EB is another diagonal. Now we'll write if theta is the angle between the diagonals. If theta is the angle between the diagonals. If theta is the angle between the diagonals. What are the diagonals? OC and between the diagonals OC and EB. Then we have the formula cos theta is equal to OC dot EB by mod OC into mod EB. Mod OC into mod EB. OC dot EB. That means this vector dot this vector. So when you simplify, it is 1 into 1. Multiply the coefficients of I and then coefficients of J and coefficients of K and add. Then you will get 1 plus 1 minus 1 by root of. Now what is the modulus of this? Root of 1 square plus 1 square plus 1 square. So it is root 3. And similarly, the modulus of EB is, modulus of this is root of 1 square plus 1 square plus minus 1 whole square. You know how to find the modulus of the vectors. So you can use the formula and directly orally you can write the values, and then when you simplify, 1 will get cancelled and then it is equal to 1 by 3. Hence it is proved. So like this we do the problem. We prove that the angle between the diagonals in a cube is given by cos theta is equal to 1 by 3. So first you have taken the unit cube and then choose the origin, choose the coordinate axis, x-axis, y-axis and z-axis along the sides, along the three corners like this, and then take the, because it is a unit cube, unit vector, all sides are of length 1 unit. So each side will be either I or j or k according to x, y, z axis, like that. So write the diagonal OC. OC is equal to OB plus BC. Again OB is OA plus AB, like that. Draw the figure. You can understand this according to addition law. These are the steps. So you'll get OC as I plus j plus k. Similarly, another diagonal EB as I plus j minus k. Then you know the formula to find the angle between two vectors. So like this we do. Now next topic is equations of planes. What are the, see, in the first chapter, in the addition of vectors, you learned about the equations of planes in the parametric form. Suppose the plane passes through 3 points. Then the equation of the plane is r is equal to 1 minus s minus t into a plus sb plus tc. If the plane passes through the points a, b and c, this is the formula. So like that you have learned 3 equations. These equations contain s and t. So these are scalars. S and t are real numbers. So this form of equations are called as parametric form. They are called as parametric forms of the equations of the planes. Now we learn the equation of the plane in the normal form. So what is the equation of plane in the normal form? So first we generally represent a plane by a parallelogram like this. What is plane? Plane is a flat surface. Plane is like a flat surface like this. And then there should not be any ups and downs. It extends to infinity in all directions. Now in this plane, you take a point. Suppose that a point P is here. A point is there in this. The plane is passing through the point A. So the point P position vector is A. The plane is passing through the point A and perpendicular to the unit vector. So the plane is, if this is the plane, this is the perpendicular. So perpendicular to this plane. And suppose that this is the origin. Then the plane is, this unit vector is taken as n cap. So if n cap is a unit vector, from the perpendicular to this plane. N cap is a unit vector perpendicular to this plane, and it is in the direction from origin to the plane. And then suppose that this is some capital N, this point. Now this length of this perpendicular, is small p. So the length of the perpendicular from the origin to the plane is small p. Then the equation of the plane is given by r dot n cap is equal to p. So and this form of equation of the plane is called as the normal form of the equation of the plane. So the equation of the plane in the normal form is r dot n is equal to p, n cap is equal to p, where n cap is the unit vector from the origin to the plane, and p is the length of the perpendicular from the origin to the plane. And n cap direction is from the origin to the plane. This point we don't need. This is different one. So the equation of the plane passing through the point. The equation of the plane in the normal form is r dot n is equal to p, where n cap is a unit vector perpendicular to the plane from the origin to the plane, and p is the length of the perpendicular from the origin to the plane. Next we have another equation of plane, where now the plane is passing through the point A. So this plane is passing through the point A and perpendicular to some vector, and it is perpendicular to some vector B. Suppose that it is in any direction. It can be in any direction. Suppose that, okay, I'll draw like this. The plane is passing through the point A and perpendicular to some vector B. So here what we do is, we'll take some variable vector point with position vector as r. Suppose that this is Q. So then PQ, this PQ vector is perpendicular to B, no? So PQ is perpendicular to, PQ vector is perpendicular to B. So PQ dot B is equal to 0. PQ dot B is equal to 0. But what is PQ? R, position vector of Q minus position vector of P. Position vector of Q minus position vector of P. So R minus A dot B is equal to 0. You can also take this as some n. Same letter you can take, but if it is unit vector, you should write n cap. If it is not a unit vector, you can just write n bar like this. So R minus A dot B is equal to 0. Instead of n, I am taking it as some B. Because n cap we are denoting by unit vector. So we are taking here as B. So this is another equation of the plane. So we have two equations of the plane now. One equation is this in the normal form, R dot n cap is equal to P, where P is the length of the perpendicular from the origin to the plane, and n cap is the unit vector perpendicular to the plane in the direction from the origin to the plane. And here R minus A dot B is equal to 0 is the equation of the plane passing through the point A. It is passing through the point A and perpendicular to the vector B. And we have some problems based on this formula. So you will be asked to write the equation of the plane passing through the point and perpendicular to some vector. So you have to use this formula. Okay, so these are the equations. Now, when you compare these two equations, you get like this. When you expand, it is because dot product is distributive, you can write R dot B. R dot B minus A dot B is equal to 0. So that means R dot B is equal to A dot B. But when this is unit vector, you can compare these two. So what we do is, we'll divide this by mod B. B by mod B will divide. Then this also we should divide by mod B. Mod B. Then what happens when you compare these two? In the place of P, you have A dot B by mod B. So if the equation of the plane is in this form, then you can write P value, that means length of the perpendicular from the origin to the plane, as A dot B by mod B. So P is equal to A dot B by mod B. In straight lines chapter, also you have this equation of plane in normal form. There also P is always P in normal form. Always P is the small p is the length of the perpendicular from the origin to the plane. So these are the points. Now we'll summarize and write all the points. So now, as we discussed, we'll summarize the points. The vector equation of the plane in the normal form is R dot n cap is equal to P. This is the equation. R dot n cap is equal to P, where n cap is the unit vector perpendicular to the plane from the origin to the plane and then towards the plane, and P is the length of the perpendicular, or it is the perpendicular distance from the origin to the plane, or length of the perpendicular from the origin to the plane. Okay, now if you take R as the variable vector in terms of Cartesian coordinates, xi plus yj plus zk, and then if you take the direction cosines, you learn about all these direction cosines in 3-dimensional coordinate geometry in 1B paper. So all that you will learn in 1B paper, direction cosines of the perpendicular. Then you will get the equation in this form. So there also you will learn about this equation of plane in the normal form. Okay, next is, suppose the plane is passing through the point A and perpendicular to the vector B, then this is the equation. Equation of the plane is R minus A dot B is equal to 0. Now when you compare these two equations, in the place of P you will get this. So this is the length of the perpendicular from the origin to the plane. Now suppose the equations of the planes are in the form. R dot n1 is equal to b1. That means some r dot some 3i plus 4j minus k, something like this, is equal to 5. This is just an example. Suppose the equation of the plane is in this form. R dot some vector is equal to some number. Then this vector is your n1, and similarly the second plane equation, this place, whatever you have in this place, that will be n2. So the equation of the angle between the two planes is given by the formula theta is equal to cos inverse of n1 dot n2 by mod n1 into mod n2. So this is how we find the angle between two planes. Angle between two planes. You can just copy all these points. Now we'll do the problems based on this. So after this we'll be completing the scalar product. We'll do some 5-6 problems. That's all. Now these are the problems. See, first one is find the angle between the planes. As I explained, when you have r dot n1 is equal to b1 and then r dot n2 is equal to b2, the angle between them is given by cos inverse of. So in the first problem, you are given n1 as equal to, n1 is 2i minus j plus 2k, and then n2 is equal to what is it, 3i plus 6j, 3i plus 6j plus k. These are the values. And then so first you write the given planes are, you write the two equations, and then you write n1, you write n2, and then you write if theta is the angle between the planes. If theta is the angle between the planes, theta is the angle between the planes, you number them as 1 and 2, between the planes 1 and 2, then theta is equal to cos inverse of n1 dot n2 by mod n1 into mod n2, modulus of this. So it is cos inverse of mod, what is n1 dot n2, 3 into 2, 6, and then minus 1 into 6, minus 6, and then 2 into 1, that is 2, by root of mod n1. What is modulus of this? 4, 2 square plus minus 1 whole square plus 2 square. So 9. So it is root 9 into root of again 3 square plus 6 square plus 1. 36, 46. So root of 46. Yes. So it is equal to cos inverse of 2 by 3 into, so it is equal to cos inverse of 2 by 3 into root of 46. So like this we do the problem. Now in the second problem, find the angle between the planes. The planes are given in the Cartesian form. So here what are n1? n1 is 2 minus 3 minus 6, like that. So in the second problem, because the equations are given in the Cartesian form, you will find n1 values like this. n1 will be 2i minus 3j minus 6k. And then n2 will be, n2 is 6i plus 2j minus 9k. So when you take r as xi plus yj plus zk, you will get some 2x minus y plus 2z, no? So here he has given the equation in that form. So according to that, you have these n1 and n2 values like this. So directly you can write n1 values, n2 values, and then the same steps. Theta is the angle between them. So you can take this as homework. Okay, now third problem is find the equation of the plane passing through the point. This is the point and perpendicular to that vector. So in the third problem, here it is the equation of the plane. So first we'll find the vector equation of the plane. So the vector equation of the plane passing through the point, vector equation of the plane passing through the point. What is the point there? According to our standard notation, it is A. Equation of the plane passing through the point. This point is 3i. You write in terms of ijk. 3i minus 2j plus k. Passing through the point this, and perpendicular to the vector. And perpendicular to the vector b. And perpendicular to the vector b. What is that b? And perpendicular to the vector b is 4i plus 7j minus 4k. Minus 4k is, we have the formula now. So r minus a dot b is equal to 0. R minus a dot b is equal to 0. So that means r minus a, r minus r, what r is r only, minus a is this. So 3i minus 2j minus k. R minus A dot B. This dot of B. What is B? 4i plus 7j minus 4k is equal to 0. Is equal to 0. This is the equation. But in the answer he gave like this. So what we should do is r dot this vector. You write this in the form r dot b minus a dot b is equal to 0. So if you write this equation as r dot, even this is correct. Even if you write in this form, this is also correct. Or because he has given the answer in this form, we'll try to get it in that form. Otherwise also even this is correct. You write the formula and then you just substitute the values. That's all. Or if you still want to simplify, you do like this. So r dot b. R dot, what is b? 4i plus 7j minus 4k is equal to a dot b. Is equal to a dot b. So what is a dot b? 4 3s are 12. 12 for a dot b is equal to 12 minus 14, 7 to minus 14 and then minus 4. So you will get this equation. So r dot implies r dot of 4i plus 7j minus 4k is equal to minus 6. Is equal to minus 6. This is the answer. But here he mentioned find the equation of the plane. So when it is vector equation, actually this should be the answer. When it is equation of the plane, you must write r in the Cartesian form. You must write r as xi plus yj plus zk. Xi plus yj plus zk. And then you substitute here. So the equation becomes xi plus yj plus zk dot 4i plus 7j minus 4k. So like when you simplify, it will be 4x plus 7y minus 4z is equal to minus 6. So this is the Cartesian form of the equation. So next, fourth problem is find the Cartesian equation of the plane passing through that point and parallel to this plane. So here in this fourth problem, so actually in the third problem, you can write the answer like this, and then again you can also write like this in the Cartesian form. This is the answer. Okay. Now fourth problem is find the equation of the plane passing through that point and parallel to this plane. So what you do is any plane parallel to this plane. What is it? 4x minus 12y. Any plane parallel to 4x minus 12y minus 3z minus 7 is equal to 0. Okay, I'll do it here. So any plane parallel to fourth problem. Fifth one you can take as homework. It is direct problem. So fourth one, any plane parallel to 4x minus 12y minus 3z minus 7 is equal to 0 is of the form 4x minus 12y minus 3z plus k. So in parallel planes, only this constant will be different. The other things will all be same. So like in straight lines also you have similar thing. Now it passes through. It passes through what point? It passes through the point 2, minus 1 and minus 4. So substitute this point here. So implies 4 2's 8, 4 into 2 minus 12 into minus 1 minus 3 into minus 4 plus k is equal to 0. So you'll get k as equal to 32. You'll get k as minus 32. K is equal to minus 32. 4 2's 8, 8 and then 12, 20, 20. Yes, for k is equal to minus 32. So therefore the required plane is, just to substitute k value in this. So you will get 4x minus 12y minus 3z minus 32 is equal to 0. So like this we do the problem. So all these are very important for 2 marks. They are all very important questions for 2 marks. Now this equation, this is direct. Find the equation of the plane passing through that point and perpendicular to this vector. So what is the equation? R minus A dot B is equal to 0. So this is your B, that point is A. Distance of the plane from the origin is given by A dot B by mod B. So you have the formula, no? R minus A dot B. So A dot B by mod B is the formula to find the perpendicular distance from the origin to the plane. So like this, you can take this as homework. This you take as homework. Now we'll do some 2-3 problems in the next period, and then we'll start vector products between two vectors. Okay.